Yeah, how happy I am that I know the hotkeys to refresh a page now.
Ooh.
That's very fancy of you, Glenn.
I know.
All right,
Who
so we're
thought?
looking
No.
at 10.4, number 17, where we have y prime is a sixth times the matrix. Oh, excuse me. Times the matrix 7, 2, negative 2, 2, y. And we have initial conditions for which we say, hooray. Okay, so first things first, I need to find eigen thingamahoots, right?
Yeah.
So in our previous, we realized that we probably need to consider this whole thing as our matrix A. And then we need to take, and you guys all do this backwards still, lambda I minus A. And take its determinant and set that equal to 0. Okay, so I have, oops, that's the wrong thing to start with. Why can I not?
That should be minus the third.
Okay, so should be, let's see, lambda minus 7/6 minus 2, regular 2, lambda minus 1/3. Oops, what did I screw up?
You have to add the 6 to the 2s?
Yeah, you need to multiply the sixth by everything, Joey, not just the pieces you want. So I have, oops, still not the right symbol, minus a third and positive a third. Let's see, so I have lambda and a minus 7/6, a minus 1/3, a plus 1/3, and a lambda minus a third. Okay, and then I need to take this whole thing, take its determinant, set that equal to 0. Okay, so I have now lambda minus 7/6 times
Fudge.
lambda minus a third plus a ninth is 0. And so I have lambda squared minus 7/6 lambda minus 1/3 lambda plus 7/18 plus a ninth is 0.
Yes.
And then I'm really annoyed by all these fractions. I'm going to resist the urge to multiply through by the...
Should be minus 3/2 lambda plus 1/2 equals 0.
hang
When
on.
you...
Oh, you're doing things for me?
Yes. Sorry.
So it's what now?
It's lambda squared minus 3/2 lambda plus 1/2 equals 0.
Cool. Okay, good. Excellent. So now that feels like I have lambda minus 1 times lambda minus 1/2 equals 0.
Yes.
Which feels like lambda is 1 and 1/2. Okay, good news. Now I need eigenvectors to go with those. And so the matrix that I'm looking at, oh good, I have it written right here. So the matrix that I'm going to sub those into is kind of this one here. This red one. Okay, so when lambda is 1 and when lambda is 1/2, I need a hotkey to change the pen's color. That would be really great. Okay, so when lambda is 1, I have a matrix that looks like 1 minus 7/6 is minus a sixth, and minus a third, and a third, and 1 minus a third is
2/3.
2/3. Oh, good. Okay, cool. I was so the hesitation that I was just experiencing is stemming from the fact that for some reason it wasn't obvious to me that the top row is a multiple of the bottom row.
Yeah.
Because fractions are hard, I guess. And this should be augmented by 0, right? Because I'm looking for what vector gives me the 0 vector out after I multiply. And so in this case, I think I end up with the idea that minus x1 minus 2x2 is 0. Because, again, the bottom row in this case is redundant with the top row. It's -2 times the top row. And I guess I can flip the signs. So that would tell me that if x2 is 1, then x1 is
-2.
-2. Okay, so my vector is -2, comma 1. And so my eigenpair then is 1. Oops, let me shift down just a little tiny bit. Is 1, comma, -2, 1. Okay, so that's one of my eigenpairs done. And the other one, I'm going to need to scroll back up so I can see again. And that's a half minus 7/6 is
2/3. And 2/3.
negative something. -2/3, you say?
Yeah.
Then I have -1/3 and 1/3 and
A 6th.
a half minus 1/3 is a 1/6. Okay, good. And this tells me that x1 plus 2x2 is 0. That scares me. Oh, that's not right. Did you guys see what I did wrong?
Yeah, it should be multiplied by 1/2, not 2.
Yep, exactly. It's like, this is bad. They can't have the same eigenvalue, or eigenvector. Okay, so I got to here, so I say, all right, so if x2 is 2, then x1 is maybe -1, I think.
1. Yeah.
And this is really, picking this is kind of up to you. I like the symmetry of having whole numbers in there. God. But if that's not the symmetry that you like to have, then you don't have to do that exactly. You pick any constant multiple of this thing and it'll work. Except for 0, don't pick 0. Right?
No.
Okay, so I have 1/2, comma, -1, 2. And that's my second eigenpair. And so what's my solution all told? Oops.
C1 -2 1 e to the t plus
Okay.
C2 -1 2 e to the t over 2.
C1 times -2 1 e to the t plus C2 -1 2 e to the what now?
T over 2.
T over 2. I see. Okay.
Shouldn't it be negative?
Sorry, 1/2 t.
Should what be negative?
E to the -t?
I think the
No.
back I have lambda is
Okay.
1. Yeah, it should be
Oh,
it should be times the eigenvalue itself.
alright.
Yeah, one of the things to remember is that at the end of the semester here, you have a lot of formulas in your head, and there are minus signs built into a couple of them, but not all of them. Like the minus signs that are baked in are in the Laplace chapter. And everywhere else, I don't think they're baked in. Okay, so now that I have this thing, what was the other part of this problem? Can I circle this?
Use your values, baby.
Oh, shit. Okay, so if I go back up and look, I have initial values, which are y of 0 is 0, negative 3. Okay. So y of 0 is 0, negative 3. Okay, so that means when I plug 0 in, I should get out 0, comma, negative 3. So 0, negative 3 should be C1 times minus 2, 1. E to the 0 is 1. And then plus C2 minus 1, 2. And e to the 0 is again 1. And so I get this little set of equations that looks like, let's see, 0 is negative 2 C1 minus C2, and negative 3 is C1 plus 2 C2. And it should be noted that this was the dumbest available way to do this. Well, I don't know. Maybe it wasn't the dumbest available way. What else could I have done?
Put it in a matrix and reroute it.
Yeah, I could have just written this as a matrix, right? I could say this is the same as the matrix negative 2, 1, negative 1, 2, augmented by 0, negative 3. And then since I have my brain in matrix mode, I could just ref that thing.
Calculator.
Yeah, exactly. Alternatively, you can solve this by hand pretty quickly, because this top equation is really the same as 2c1 plus c2 is 0, which is that c2 is minus 2c1. And then this guy becomes minus 3 is c1 minus 4c1. So that's negative 3c1. So c1 has to be 1, and then c2 is negative 2. Or you can ref it and you'll get the same thing pretty quickly. And then we can just go up. Sorry, say again?
When C2 have to be positive too?
C1 is 1. And so 2 plus C.
Oh, sorry. I thought it was negative 1.
No worries. It's all good. It's hard to read my handwriting on this thing. Okay. Cool. So then we could go up to our initial thing and be like, whoopsie-doos about this guy and this guy. Right? And we can just erase these. And then plug in our values, which are 1 and negative 2. And then actually, I suppose this one doesn't really need to be there. And on this other one, I can like fold that into the vector if you want, whatever. It's up to you. Questions, concerns, things?
No.
Where were you getting hung up? Was it the constant up front again?
Yeah.
It was an algebra error.
Oh.
And just like pure laziness, I was like, no, I don't like this.
Yeah, so one thing you can do with these that I kind of encourage you to do at any rate is you can just look up a calculator for eigenvector value pairs and just use the results. That's totally fine. I would like you, I guess, to have some familiarity with how they're calculated. But if you want to use a computer utility to get them right every time, I don't mind that.
I'm real familiar.
I think I'm gonna try doing that now.
Yeah, I mean, it's one of those things, like, you'll see a lot of people do 2x2 determinant kind of stuff, like finding eigenvalues and eigenvectors by hand. But the fact of the matter is it's not really all that often that you get a matrix this small to work with on a real world problem anyway.
Yeah.
And I suppose if you're working at an engineering firm and your boss walks in and you're calculating determinants by hand, they probably won't fire you on the spot, but
They'll scold you for it for sure.
yeah, I would imagine that they pay money for, well, in fact, I know they pay money for lots of computer programs so that you don't screw it up.
Yeah.
And introducing any possibility of human error into building things is already so much an issue that I would imagine they try to eliminate that at every turn.
Cool.
Okay, other questions?